All right, welcome to another deep dive. This time we're going behind the scenes of online security. We're exploring RSA encryption.
Oh, yeah.
You shared a chapter from a document all about this, and I have to say, it's quite a thriller.
Mm.
We're going to unpack how RSA works and its significance, and what its future might look like, and trust me, there are a few surprises along the way.
Definitely some surprises.
So ready to unlock the secrets of digital security?
Let's get started.
Okay, so first things first, why should we even care about this stuff?
Right.
Well, think about everything we do online, like banking, shopping, sending messages. It all relies on the internet, which means we have to trust these systems with our sensitive information.
Absolutely. And it's not just about today's internet either. The need to protect information, well, that goes back centuries.
Oh, I bet. We've all heard about ancient codes and ciphers like Egyptian hieroglyphics or the famous Caesar cipher.
Right.
Those were amazing for their time.
They were ingenious.
But they all had one major flaw,
Yeah, they've
the
owned.
shared key problem.
Uh-huh.
So imagine having this super secret code, but you need to send the key to your friend through an insecure channel. Not exactly ideal for keeping secrets.
Not at all.
It's like trying to whisper a secret in a crowded room.
Right.
Someone's bound to overhear.
Exactly.
And that's where public key cryptography comes in, right?
Yes.
It was a total game changer.
It really was.
This revolutionary idea that emerged in the 1970s with Diffie and Hellman,
Mm-hmm.
they proposed a system with two keys. A public key for encrypting messages and a private key for decrypting them.
Yes.
I always picture those old-fashioned mailboxes where anyone can drop a letter in, but only the person with the key can open it and read it.
That's a great analogy.
It's an easy way to understand a complex concept.
It is. And this is where RSA comes in. It's the algorithm that brought this elegant concept to life. Named after its creators, Rivest, Shamir, and Adelman.
RSA, the star of our deep dive today. But how does this mathematical magic actually work? The chapter mentions prime numbers, and I have to admit, that always makes me a bit nervous.
Well, it's actually very clever. RSA relies on the fact that it's really difficult to factor large numbers, especially those that are the product of two very large prime numbers. It's like a one-way street, mathematically speaking.
Okay, pretend I'm back in high school math class,
Yeah.
but without all the daydreaming this time.
All right, so imagine choosing two prime numbers, let's say 61 and 53. When you multiply them, you get 3233. This becomes part of your public key, the one everyone can see.
So 3233 is out in the open, no secrets there.
That's right.
But the secret is in those two prime numbers used to get there.
Right.
So cracking RSA is like trying to solve a giant jigsaw puzzle, where the only way to see the picture is by finding those two starting pieces, your prime numbers.
That's a good way to think about it.
So the bigger the numbers, the harder the puzzle is to solve.
Exactly. There are a few more steps involved in generating the public and private keys, but the core concept is this. Only the person with the private key, which is linked to those original prime numbers, can actually decrypt the message.
Okay, so even if someone intercepts the message and they have the public key, they're basically locked out.
Exactly. They're missing that crucial piece of the puzzle, the private key. That's why RSA has been a cornerstone of digital security for so long, because it's been remarkably difficult to break.
But like any good story, I'm guessing there are a few twists and turns ahead.
Oh, there are.
Okay, so before we get to those twists, can you give me some examples of where RSA shows up in our everyday digital lives?
Well, it's likely playing a role in our conversation right now. RSA is often used in the SSL/TLS protocol that secures communication between your browser and websites. You know that little padlock icon you see in the address bar?
Mm-hmm.
That often means RSA is at work making sure your data is encrypted and safe from prying eyes. Think online banking, shopping, or anytime you're entering sensitive information.
Wow, I'm suddenly feeling very appreciative of RSA.
It's protecting more than just your browsing, though. Think about digital signatures, which are used to verify the authenticity of documents like contracts or software downloads. They ensure that a document hasn't been tampered with, and it really came from the source that it claims.
Right.
RSA is often the technology behind those digital fingerprints.
It's incredible how something based on prime numbers has become so integral to our digital world.
It really is. And let's not forget about messaging apps. Many of them use RSA to initially exchange session keys, which are then used for secure communication during your conversation.
So even those quick messages we send are touched by RSA's invisible hand.
Pretty much.
That's amazing.
And then there's the world of cryptocurrencies, like Bitcoin. While they don't directly use RSA, they rely heavily on public key cryptography. using similar principles to secure transactions and manage digital wallets.
It sounds like RSA is everywhere.
It is.
But the chapter also hinted that this seemingly unbreakable code faces some challenges. Should we be worried?
What?
I guess we'll find out after the break.
Yeah. RSA faces some challenges for sure.
Like what?
Well, one of the biggest concerns is the rise of quantum computing.
Quantum computing. It sounds like something straight out of science fiction.
That kind of is.
What makes it such a potential threat to RSA?
Well, quantum computers work completely differently than the computers we use every day. They leverage the world of quantum mechanics,
Right.
which lets them do computations in ways that are, well, hard to grasp. One thing they could excel at is factoring large numbers,
Which is?
the foundation of RSA security.
Oh, so it's like they have a secret weapon to crack the code that's been protecting us for decades.
It's a possibility. Practical quantum computers that can actually do this are still some years away. But cryptographers are in a race against time to develop new encryption algorithms.
Post-quantum algorithms.
Oh.
It sounds like we need some new digital superheroes.
We might.
But even without quantum computers, you mentioned that RSA has other vulnerabilities.
Yeah. The math behind RSA is solid, but things get tricky in the real world. Algorithms need to be implemented in software and hardware, and that's where things can go wrong.
So it's like having a blueprint for a perfect safe, but someone messes up during construction and leaves a weak spot.
Yeah, kind of like that. There have been cases where vulnerabilities exploited flaws in how RSA was implemented. One example is the RSA vulnerability a few years back. It shows how important it is to have really good coding practices and to keep checking for those weaknesses before the bad guys find them.
It's like we need constant security audits.
Exactly.
It reminds me that even the best tech needs attention to detail.
Yeah.
Any other challenges we should be thinking about?
Well, another challenge is computational efficiency. RSA can be pretty resource intensive, especially as we use larger and larger keys to try and counter those attacks. This can be a problem for devices with limited power, like smartphones or all those smart devices in our homes.
The Internet of Things.
Yeah, exactly.
So it's like trying to run a huge program on an old computer. It might work, but it'll be slow.
Exactly. That's why researchers are always exploring alternatives to RSA. Alternatives that provide strong security without needing as much computing power.
Okay, so it seems like our digital security hero has some weaknesses.
It does.
Where do we go from here? What are some of those alternatives you mentioned?
There are some exciting new developments. One is called elliptic curve cryptography, or ECC.
ECC, I've heard that name before. What's so special about it?
Well, ECC is kind of like RSA's more agile cousin. It can offer similar levels of security, but with much shorter keys. This means faster computations and less strain on resources, which makes it perfect for those less powerful devices we were talking about.
So it's like a lean, mean fighting machine, ready to protect our increasingly mobile world.
That's one way to think about it.
What else is out there?
Another exciting area is lattice-based cryptography. It's getting a lot of attention for its potential to resist quantum attacks.
Quantum proof? How does that even work?
It's a bit complex. It's based on the difficulty of solving certain mathematical problems. Problems that involve lattices, which are kind of like geometric structures. So far, it's looking really good at resisting attacks from both classical and quantum computers.
So lattice-based cryptography could be our digital shield of the future.
It could be.
What else?
There's also something called homomorphic encryption. It might sound like it's straight out of a sci-fi movie.
Homomorphic encryption. That one definitely caught my attention.
It did.
What's so futuristic about it?
Well, imagine being able to perform calculations on encrypted data without ever actually decrypting it.
Wait, seriously?
Seriously.
It sounds impossible.
It involves some really complex math, but the potential applications are incredible.
Okay, I'm hooked. What kind of applications are we talking about?
Think about cloud computing. Imagine storing your sensitive data in the cloud, but encrypted. With homomorphic encryption, you could still do calculations on that data without anyone, even the cloud provider, ever seeing the actual information.
So no one would ever see my data.
Not even the cloud provider.
That could revolutionize how we think about privacy in the cloud.
It could. It's still early days for homomorphic encryption, but it has huge potential. What's clear is that the future of encryption is full of innovation.
It's amazing to see how this field is always evolving.
It is.
It's like a constant race to stay ahead of the bad guys.
It is.
And it seems like we have some brilliant minds working on it.
It's a testament to human ingenuity. We face new threats, but we also develop incredible solutions.
It's a fascinating time to be following digital security.
Is.
The story of RSA is a great example of how abstract mathematical ideas can have a huge impact on our lives.
Definitely.
It makes you realize that we often take for granted the complex systems that keep our online world running smoothly and securely.
We do.
But what about the human side of all this? We've talked about algorithms and technology, but what about the people behind these innovations?
That's a great point. These breakthroughs don't happen in a vacuum. There are researchers, mathematicians, and cryptographers who are pushing the boundaries of what we know.
It's like they're digital guardians,
That's a good way to put it.
protecting our online world.
It takes more than just technical skill, though. It also takes creativity and collaboration, a willingness to think outside the box.
Like Diffie and Hellman.
Exactly. They completely changed how we think about cryptography.
So we need to create an environment where those kinds of ideas can flourish,
Yay.
where people can collaborate and build on each other's work.
We do.
It's inspiring to think about the discoveries that are waiting to be made.
It is.
But as we learn more about encryption, we also have to think about ethics and responsibility. With these powerful tools, how do we make sure they're used for good?
That's a big question. Like any technology, encryption can be misused. It can protect privacy, but it can also hide illegal activities.
How do we balance that?
It's complicated. It requires us to think carefully about the ethics of these technologies and to have open conversations about it, involving not just tech people, but also policymakers and the public.
It's a reminder that technology doesn't exist on its own. It's part of our society.
It is.
And speaking of the future of encryption, we can't ignore the potential impact of quantum computing. If these powerful computers become a reality and our current encryption methods aren't safe anymore, what will that mean for us? Will our online world be thrown into chaos?
It's a real concern. That's why post-quantum cryptography is so important. It's not just about replacing RSA, though. It's about rethinking how we approach digital security in general. We might need entirely new ways of thinking about it.
Like new paradigms.
Exactly. Ones that go beyond our current ideas.
So a fundamental shift.
Possibly. It's an exciting challenge for the next generation of experts. And exhilarating.
I agree.
As we keep pushing the boundaries of technology, we need to talk about responsible innovation.
Absolutely. We've covered a lot of ground today, from how RSA works to the threat of quantum computing and the new technologies that are emerging.
We have.
It's clear that digital security is constantly changing.
It is.
It's been an amazing deep dive.
It has.
I hope you've enjoyed it as much as I have. It really feels like we're on the brink of a whole new world, a new era of digital security.
It does, doesn't it?
What's with all this talk about complex algorithms and scary threats, I can't help but think about, the average person like me. It can feel kind of overwhelming, to be honest.
Yeah, I get that.
How do we navigate this crazy world and actually keep ourselves safe?
That's the million-dollar question. And the good news is that you don't need to be a cryptography expert to protect yourself. There are simple things everyone can do right now to be safer online.
Okay, I'm all ears. What are your top tips?
Let's start with the basics. Passwords.
Passwords.
I know. We hear it all the time, but it's true. Strong, unique passwords are your first line of defense.
Okay, but what does that even mean? Strong and unique.
It means not using the same password for everything.
Right.
And not using easy-to-guess passwords like password 123.
Definitely not.
Think about using passphrases instead.
Passphrases.
Yeah, longer phrases that are easy for you to remember but hard for hackers to crack.
So like a line from my favorite song?
Exactly.
Or a quote from a book?
Yeah, something personal and meaningful to you.
But not obvious to anyone else.
Right. And whenever you can, turn on two-factor authentication.
Two-factor authentication. I've seen that.
It's like having an extra lock on your door. Even if someone gets your password, they can't get in without that second factor.
Makes sense.
What else?
Be careful about phishing scams.
Phishing scams.
Yeah, those emails or messages that try to trick you into giving up personal information.
Oh, those.
Don't click on suspicious links or open attachments from people you don't know.
It's like being street smart, but online.
It is. And keep your software up to date.
Those updates usually include important security fixes. They're like plugging holes in your digital armor.
It's good to do some digital maintenance.
It is.
Any other advice?
Be mindful of what you share online. Do you really need to give all that information?
Good point.
Be selective and protect your privacy.
Mm-hmm.
And remember, encryption is your friend. Use encrypted messaging apps. And look for websites that use HTTPS, the ones with the little padlock in the address bar.
Oh yeah, I always look for the padlock.
It's a good habit.
Speaking of encryption, we talked a lot about RSA and its problems.
We did.
Should the average person be worried?
Stay informed, but don't panic. Researchers are already working on post-quantum encryption algorithms. They're designed to be secure even against those super powerful quantum computers.
So they're like the next generation of digital superheroes.
I like that.
Ready to take over when RSA is no longer strong enough.
Exactly.
Many organizations are already planning for this transition,
They are.
so it's not something we need to worry about today.
Not today, no. But it shows how the world of digital security is always changing.
It's a constant game of cat and mouse.
It is.
But it's not just about individual actions, right?
Right.
We need to think bigger. We need to foster a culture of security on a societal level.
I agree.
How do we do that?
It starts with education. We need to teach people how to navigate the digital world safely, starting from a young age.
Like digital citizenship classes?
Like that. And we need to have honest discussions about the ethics of technology.
Like how to balance security and privacy?
Exactly.
How to use these tools responsibly?
Exactly.
It's about building a digital world that's both safe and ethical.
Well said.
Wow, we covered a lot today. From the inner workings of RSA to the future of digital security.
We did.
It's been an incredible journey,
It has.
and I hope our listeners have enjoyed it.
Me too.
So until next time, stay curious, keep learning, and stay safe online.
Great advice.